Hello and welcome back to another video by Lathe Plans. Today we're at the lathe. Lots of people had been commenting on some of my other videos. If you've been on my YouTube channel and seen some of the other videos, you'll see that I've been buying a whole bunch of workshop equipment, machines and tools and all that kind of stuff, driving miniature steam engines and going on trips, and basically not been doing much on the machines or using any tools. So yeah, a lot of people commented saying they wanted to see more of that kind of content. So today we'll be making a bunch of these guys. So yeah, follow along. Hopefully you enjoy the video. If you do and you think it deserves a subscription, then feel free to subscribe, obviously. But yeah, I'll see you guys on the other side. Hello and welcome back to another video by Lathe Plans. As you may know, all good projects start with a nice cup of tea, some biscuits, a spreadsheet and a sketch pad. So lots of people had been commenting that they wanted to see more projects and builds and making stuff. If you've been watching some of my other videos recently, you'll notice that I've been buying every machine you could need for a workshop and driving steam engines and things like that. So this is going back to my original videos of actually making projects on the lathe. You can also see here I'm using a stencil. I recently bought a drawing board and a bunch of stencils and things, so that's a video that'll be coming soon as well. Anyway, today we're going to be looking at a beginner project, and it gets you familiar with using the lathe again. I've not used the lathe for nearly 6 months now, so yeah, this is a great project if you're just starting on a lathe, or if you've not used one for a while and you just want a practice project. So, what are we making? As you know, the simplest thing to make on the lathe is a cylinder, and this project is all about making as accurate a cylinder as you can on your lathe with your tools and the materials that you have at hand. To make it a bit more interesting than just knocking out a cylinder of any particular size, I've modified some maths equations which let you specify a weight that you want and a ratio between the diameter and the height of the cylinder, and also let you input your own density of material. So if you're using aluminium versus brass or bronze or whatever, you can substitute in those densities. And the spreadsheet will actually calculate exactly what height and diameter you need to get to for the weight that you've specified, and also the ratio between the diameter and the height and your density of material as well. Dead simple project. It's just a cylinder, as you can see here. I've got a whole bunch of equations and things showing you how all this works, so I'll run through these on the computer so you guys understand what the formula is and why it works the way it does. But yeah, it's basically just a dead simple cylinder. You can specify the ratio between the diameter and the height as well. So if you want a short stumpy cylinder, dropping stuff. If you want a short stumpy cylinder, you can do that. If you want a big tall skinny cylinder, again, you can just punch those ratios in and the spreadsheet will work everything out for you. So yeah, I'll run you through the whole process of the calculations first. Then we'll look at picking stock, and then we'll look at calculating the mass of the material that you have. You might have a whole bunch of stuff in your scrap bin there, so I've got all sorts of different materials in here. You can mostly see the brass poking out the top, but I have a whole load of stuff in here. So this project was designed to be able to use any material, right? You can just punch in whatever density for the material that you have. If you have really skinny material, you can make short or skinny weights. If you have big fat chunks of material, maybe you don't want to turn all that into swarf to make a tiny weight, so you can make a much bigger weight. So just gives you a bit of practice making some stuff to a specific dimension, and yeah, hopefully you enjoy it and make some of your own, post some in the comments, tell me how accurate you got. So now we're going to flip over and we're going to go to the computer and I'm going to talk you through the spreadsheet and a couple of the calculations that are needed. Okay, time for the maths now. So the purpose of this project is we want to specify the target weight of a cylinder that we're going to machine. By knowing the density of the material we're using and knowing the target weight, we can calculate the target volume of material we need, which will give us the weight. And then, because we're also defining the relationship between the diameter and the height, we can use the equation pi r squared times height, which gives you the volume of a cylinder. So we can rearrange that equation so that we can work out the diameter and the height of a cylinder to give us the weight that we want. The rearranged calculation is the cube root of 4 times the volume divided by the ratio, and that gives the diameter. Simples. See, maths is easy. So now that we know all of the calculations that need to be done, here's a spreadsheet that I said I'd made. Okay, so we'll start off in this corner here. So this is our density checker or density calculator. So this allows you to calculate the density of your material that you're using. So if we have a cylinder or a piece of bar, we can measure the diameter, measure the length, weigh it, and that'll calculate the density of the material in grams per cubic millimeter. So I'm using metric because I'm a civilized human being. Apologies to anybody not using metric. You can obviously do the conversion if you want to divide everything by 25.4. Anyway, so here you get the density of your material. So this density is then used over here in this square here. So this just relates back to this square here. So once we've calculated the density of the material we're using, we can come over to this section here, and this is where we can enter the ratio between the height and the diameter of the cylinder we want to create, and we can input the target weight. We've specified here that we want a 1-to-1 ratio between the diameter and the height. Bear in mind, this is diameter, not radius. The spreadsheet here does actually use diameters, not radiuses, because we measure diameters. But yeah, we have a 1-to-1 here. So for a 15-gram weight with a 1-to-1 ratio and this density, we need a volume of 1,774 cubic millimeters. That gives us our 15 grams. And so with a 1-to-1 ratio, this is the diameter and the height that we need to get. And they're the same because we have a 1-to-1 height to diameter ratio. If you want the cylinder to be twice as tall as it is fat, that would be a 2-to-1 ratio. So if we put a 2 in here, then you can see that the diameter has shrunk a bit and the height has grown a bit. So instead of being about 13.5 mil, it's now 10 and 20 mil. So you can see here that the diameter is half the height. So down here we have a checking section, and this just takes the outputted diameter and height, calculates backwards, and makes sure that you get the correct mass from the calculated values that it's given. So it just checks to make sure the maths is correct. So this number should be the same as the target weight that you entered up here, which it is. So now that you have your optimal values, these are the nominal values that you're aiming for when you make your cylinder now. So if you make a cylinder with the material that you've specified here, with the density here, and you hit these values, you will get a 15-gram weight. Now, that's the optimal values. What I've done here is I've allowed for some tolerances. So if you want to be within 0.1% of the nominal values, this gives you a minimum and maximum for each. For the diameter, diameter is this row, height is this row. If you want to be within 0.01 millimeters, and this is a dimensional accuracy, so if your tolerance is 1/10 of a millimeter, these are the values that you need to be between. So anywhere between 10.314 mil and 10.514 mil, you'll be within tolerance. And then lastly here, if you want to specify the weight that you want to be, so plus or minus in grams. So this was a little bit more complicated to calculate, but it works. So if you want to be within 0.01 of a gram of your target weight, this tells you the minimum and maximum values that you need to be for that target weight. And you can modify these tolerances here. So if you want to be within 0.05 of a millimeter, which is quite a wide tolerance, then obviously these figures all update. So really, these are the figures that you should be aiming for. You want to be in between, for the diameter, you want to be in between these two figures, and for the height, you want to be in between these two figures. And you can specify the tolerance that you want to get to. So if you want to be within 0.01 of a millimeter, well, then these are the dimensions that you need to hit. And that will give you a weight between these two weights, because we also confirm the mass as well at the bottom here. So if you get within 1/100th of a millimeter of the nominal values of these values here, you will have a weight that's between 14.96 and 15.04. So you'll be plus or minus 0.04 grams away from the target value that you want to be at. So, like I said, this project is fantastic because it gives you practice on hitting the targets, and it gives you a second way of verifying if you're on target, because not just by measuring, You can also weigh your cylinder at the end as well, and that will verify if you've got on target or not. So if this project does interest you, download this spreadsheet, fill in the values in yellow here, so you can calculate your density here, and then you can specify the cylinder that you want to produce here, and then you can aim for these green figures here. There's one other section to this spreadsheet which is pretty cool. If you come down the bottom here, you can, once you've made your cylinder, you can input the measured values. So let's say that you were aiming for a 15 gram weight with a 2:1 ratio, and these were the figures you're aiming for. Let's say you want it to be within 1/100th of a millimeter. You can enter in here what you actually produced. So this is where you measured your cylinder at the end. So you've cut your cylinder, you've allowed it to cool back down at the end, and you can input. So let's say you're aiming for 10.404, you actually got 10.412, let's say. So this will say that you were within 2/1000ths of a millimeter. You were 2/1000ths of a millimeter under because you were going for 4.414 and you're 4.12. So that's 2/1000ths. Make sure when you're calculating your density and specifying the values for the cylinder that you want to make, you need to just make sure that the calculated diameter and height are within the bounds of the material you're using. Obviously, can't produce a cylinder which is larger than the stock that you're using. So you may need to fiddle around with these values to get a cylinder of the size that you want and the ratio you want with the stock that you have available in your scrap bin. But that's the purpose of this project. It can work for anything. If you have smaller material and this is too big because your bar is, say, 10 mil nominal value, well then you're going to have to make a 12 gram weight, and then these all drop. So you now have a 12 gram cylinder instead of a 15 gram cylinder, but at least you can make it. Or you can change the ratio, so you can maybe make it 3:1 instead of 2:1, and all the values will update for you. I have a bunch of these all over my desk. Whenever I get back to the lathe after a while of not using it, I knock out a bunch of these. So that's the spreadsheet. If that interests you, make sure you download it. The link will be in the description below. And yeah, I'd love to see in the comments how you get on. So yeah, post and tell me, were you within your tolerance that you specified? And was your cylinder the correct weight when you'd finished up? So that's everything on the spreadsheet. So let's go to the lathe now, and I'll show you the process that I took to make a couple of these cylinders. So, after all that, what are the steps that we need to go through to make this? Well, first of all, we need to calculate the density of the material you're using. If you know the exact material that you're using, you could just Google it and that'll tell you the density. If, on the other hand, you have an unknown material or you're not sure of the specific alloy that you have, you can just measure the density. So if you have a bar that's got an alright surface finish, you can just face off each end, just measure the diameter and the height. Or if you have a bit of a bashed up bar, it might be worth doing a longitudinal cut just to make sure that you have got a nice regular shape. And so that's exactly what you can see me doing here. So as you can see, the piece of bar that I've got, which I'm going to use to calculate the density with, this bar has got a hole in it. So I'm just going to face off both ends so that they're flat and square, and then I'll measure the dimensions and they'll get put into the spreadsheet as you saw, and that will give me the density of this material. And then I'll also use this same slug to actually make the weights as well, so I know it's exactly the same density. You can see here I'm facing off the other end of the bar, and although it looks like a fairly straight cut, once I've done the first pass of the facing cut, you can see there's actually a chunk missing of the corner, and that's why we face both ends off. It gives you a much more accurate calculation for the volume, which in turn will give you a much more accurate calculation for the density of the material, which means you can make more accurate weights. Now that I've squared off my bar for calculating the density, you can see that I'm measuring it, weighing it, and inputting the values into the spreadsheet to calculate the density. Now that I have some accurate measurements for the diameter, the length of the bar, and the weight, I'll punch these into the spreadsheet, and that will give me the density value I need to be able to make my weights. So now that I have the density value, I've punched in the numbers on the spreadsheet for a couple of weights that I want to make. And here you can see me marking up the material and then reducing it down to the dimensions on the spreadsheet. So I love this project. It's great if I've not been using the lathe for a while, and it's also great for beginners as well because it gives you a chance to practice your accuracy, and it gives you another way of measuring how accurate you've been, because you can measure the weight as well as obviously the diameter and the length of bar that you've cut. So it does make it a little bit more interesting. So why is this good for beginners? Well, it's a great starter project because obviously cylinders are the simplest thing that you cut on a lathe. It's just a straight bar with a facing cut and then parting it off. You can make this project with any material. You can pick the sizes based on the stock that you have available in your scrap bin. So if you've only got tiny bar, you can make really, really lightweights. If you have big, fat, chunky lumps of bar, you can make some big heavyweights if you want to. But yeah, I wanted a project where I could basically pick the material and I didn't have to use brass or aluminium or whatever. So this is a totally flexible project where you can use any material that you have lying around and you can still finish up with a usable product at the end of it. On the spreadsheet, there is a section there which lets you specify your tolerances. This was more a bit of fun than anything else, but yeah, if you're very, very new to the hobby, you might want to be a bit more lenient on your measurements. You know, if you're really good, like Joe Pye or whatever, you'll be able to nail these down to like 10 microns or something. So yeah, knock a few of these out and see how close you can get to the nominal value. You will get better over time. So yeah, just have a play, knock a few of these out, and you'll end up with a whole bunch of very accurately weighted paperweights. You might be wondering where this came from. This was actually a broader project where I wanted to make a set of weights, and I wanted every weight to have the same ratio of diameter to height, so that when you stood them all next to each other, they all looked the same, just different sizes. And that's how I devised the spreadsheet. One thing to bear in mind with this is as you make larger and larger parts, the same dimensional inaccuracies will lead to much, much greater weight inaccuracies. So if you're 0.03 of a millimeter oversize for a 5 gram weight, you may still be within 1/10 or 100th of a gram. However, that same dimensional inaccuracy on a 250 gram weight might mean you're actually out by maybe up to as much as 10 grams. So just bear that in mind when you're doing this project, right? That the bigger you go, the harder it is to hit the weight. So hopefully you enjoyed this video and you thought making a few of these little cylinders might be interesting. Do let me know in the comments below if you actually did make any of these and what sort of accuracy you got to. Feel free to post in the comments or put some links or link to your own video of you making some of these. And yeah, thanks for watching and I'll see you in one of my other videos. Thanks, bye-bye. Thanks for taking the time to watch this video. If you want to see more, click one of the links on the screen now or go and check out the Best Lathe Plans YouTube page. Stay safe and I'll see you soon.